Okay, this is the second video segment that I'm going to be making on parameterizing an assembly. The first one that I did, I not only put some dimensions in there, one length dimension, two angle dimension. It was the wedge problem. I also created string parameters which allowed me to change the name of the parts, the wedge, and the material of the parts. If you, I'm not going to do that here. I will only do the problem that deals with uh, dimensions. Okay. There are some other tutorials where angle is also concerned. I didn't do that in class, but it was done last year for some other class, and I will give you the reference to it on the day-by-day highlighted lectures. Okay, which is not good. Obviously, I'm not going to lecture on that. Now, the problem that we're going to do was to see it right in front of you. So we have a cylinder basically on the top. It's got radius RS and height of L2. And then this is supposed to fit inside of that bottom piece. Let's call this thing the base, if you want. And it's got as parameters RS. So that shaft on the top should fit snugly inside of that inside cavity of the bottom piece. And then there is the outer radius RB. And there are holes around that which are exactly halfway between the outside and inside, radii. So these holes I'm talking about these holes, okay? And of course, the height of it is L1. All right, the one thing I want to point out to you, when you look at this problem, um, everything is L1, L2, RS, RB, and R. These are length dimension, but the number of holes is neither length nor angle nor a string. It is actually what Catia calls real. Real means that there is no units associated with it. So if I say 5 holes, there is no unit associated with that 5. When I say 5 apples, that 5 has no dimensions. Okay, that's what Catia calls the real number or real parameter, which is a misnomer, really. Okay, so let's go ahead and make the nominal ones. First thing I'm going to do is I'm going to start the Catia product file. Product. Immediately save. File, save management, save as, desktop, a new folder, Parametrize, assembly, problem 2. Put it in there. And then we're gonna let's do that simple disk or shaft first. So insert a new part in there, just so that it reminds me what this thing was. So I'm gonna change the name of it to shaft and shaft. Okay, let's go make it. Double click on a convenient plane. On that horizontal plane, I will sketch a circle. Later on, the radius of this circle is going to be your RS, okay? And might as well dimension this thing. Exit, pad it. Some height. Excellent. Now, as I said, I'm not going to worry about material or name parameterization. So if you want, watch the other video segment, please. You may want to do it for your own good. Okay, so go here and save. And then we're going to insert the next part. Insert a new part in there. And I'm going to call this thing the base. Right click, properties, base, and base. Okay, let's do it. Double click on this so that we go into part design on a convenient plane. On that horizontal plane, I will sketch. If this shaft is bothering you, I can always hide it. It really is not playing any role right now. So this is the opening for the base. This is so it's going to be RS later on, and this is the RO. Okay, the outside or big or so. Let's dimension these things. This is going to be eventually RS, and this one is going to be eventually RB. S stands for small, and B stands for big. Okay, now this circle has to be exactly halfway between these two. So right now, it really doesn't matter. I can exit first of all. I can exit and pad this. There are different ways of doing the problem, of course. This is how I'm going to do that. On that plane, I will sketch because I want to make a pocket. Okay, the alternative is use holes and things like that. So I'm going to put the circle right here. Okay, dimension this. Dimension it, and also dimension the distance from the origin to the center of that circle, because this eventually is going to be equal to half of RB plus half of RS. Exit, and then we pocket all the way through. Let's say all to the end, to the last. Okay, it goes all the way to the end. Okay, good, good. Now, what I would like to do is to make a circular pattern of this, because and of course the number of these the number of the repetition is going to be a parameter that I'm going to specify later on. For now, let's just go ahead and make a circular pattern. Okay, so we want a complete crown, and for now let's make it four pockets, 4 holes. And reference element is basically the axis along which the pattern is going to be made. So for example, you can select this, or you can select the outside edge. And I don't want to pattern the entire solid object. I want to pattern that pocket, only the pocket. You might say, well, what difference does it make? Well, it does make a difference in the database, but it may even work for your purpose, but they are different. Okay, good. So what we have done is we basically have created everything that you want. If you want the shaft, we can bring it in the front. Right there, it is there. Okay, and let's go to the assembly level. Very important, assembly level. And if you want, you can put assembly constraints here. And by the way, the assembly constraints are very straightforward. I want the axis of this shaft to be coincident or with the axis of this base, and I want the plane of this shaft be coincident with the plane of that base. Okay, now when I rotate these things and rotate arbitrarily, and for example here, let's see now, move arbitrary rotation about the z-axis. Let's make it y-axis. Z-axis doesn't do anything, and there we are. And when I update, they should go back where they were according to my constraints, and they did. We can see that. Very good. Okay, so now we're going to create our parameters. Remember, if you're doing parameterizing an assembly for my course, these parameters that you create must be at the assembly level. In other words, you should be at this level when you create your parameters and make any formulas if necessary. All right, or you must have a double gear on the side to ensure that you are actually at the assembly level. Okay, so let's go ahead and do that. Let's go create our parameters. So we click on f of x. Okay, click on f of x right there. And let me remind you how many parameters we've got. We want RS, RB, that's 2. Our radius of the circle is going to be 3. And then L1 and L2, L1 and L2. So that is 5. Now, the distance being exactly halfway between, we can say that that dimension that we created is half of RB plus RS. We don't need another parameter. We make it an equation. 5 plus the number of the repetitions of that pocket. So that is 5 length and 1 real. So we go here. Let's worry about the length first. So I'm going to change this to length. First one, RB. Let me give it a nominal value, for example, 6 inches. Apply. Another one, RS. Let's give it 3 inches. Apply. Notice that as I'm creating these parameters, if you look at your tree, the parameters are created at the very bottom of the tree, okay? Below the parts. So it is being created at the assembly level. If you don't see them popping up there, means that you are not at the right spot. Okay, so another one. Another one is going to be the radius of those little holes which we made the pocket. So we make it R. And let's make it, for now, some tiny number. I don't know, 0.5, because I don't want it to have a self-intersecting curve. Apply. Then there is the length of these things, length of the path. New parameter, I'll call it L1. For now, I'm going to make it, I can't remember which one was which. L1 was the base. Okay, so let's make it a 1. Apply. And L2 was for the shaft, which is, I mean, right now it looks taller, but let's make it 3. Apply. And we also need a real, check here, a real parameter, and I'll call it N, the number of these pockets. Apply. And give it some value. If I say 0, of course, there won't be any repetition, so I'll make it 6. Apply. And okay. Now, at this point, we're going to make our any equations, well, the equations that we need. For example, we'll see. One thing I want to show you here is that if there's too many planes, there's 6 planes here, and I want to hide it, so I can do one by one, or you can do a search. So you can do a search and say select them all and hide it. Let me do that for you here. So where is the search? Edit, search. Okay. So what we want is in the part design. The type that we want is any plane, because if there's so many of them, then it's a hassle to go through, find them all, and then they say find it and pick it, search and select right here, and then you put the cursor on one of them and say hide. All of them are going to be gone at the same time. Also, let me hide this these constraints. Okay, good. So we click on f of x, move this thing on the side, move this thing here, and let's click on the shaft. Okay, notice the dimension of the shaft shows up. This is the radius, and I want to say add a formula equal to RS, small radius. And I select the height of the pad, which is, where's the height of the pad? Okay, let me say apply. Okay, and I want the height of the pad. So oh, that's right here, right there. You see that shaft? Add the formula, rename parameter. That's L2. And then I select on the base, and let me hide the shaft. I don't need it. Okay, so let's see now. This is the, see, that's the radius of the hole. Add the formula equal to R. This is the RB, the big radius. Is that right? Oh, I'm not sure here. Just a second now. Which one is which? That was okay. This one is... I have a suggestion here because it's kind of hard to see what is going on. I know what this thing is. This thing is the distance from the center to the center of that guy. So might as well we do this this equation. So add a formula equal to half of RB plus RS. That I can see. It's easy to see here. So RB plus RS divided by 2. Halfway between, and let me say okay here and update because I cannot see these other radii quite easily. No, actually it's not bad. This one, that one, yeah, that one is the radius. Yeah, that one is the radius, the big radius. I can see that right there. It goes all the way to the end right there. Okay, so this is RB. Add the formula equal to RB. And the other one is your RS. So this must be the other one. This must be your RS. Yeah, that must be your RS. Add the formula, rename parameter RS. Okay. Now, the height of the pad is right there. This is the first pad limit. You can see that. Add a formula. That's equal to L1. Oops. I don't have the L1 here. For some reason, I must have not done that. We can fix it. That's fine. So cancel that. Okay. So let me see whether I did actually create L1 or not. The assembly level. Let's see. The assembly level. Yeah, you see, I forgot to do L1. So let's do a. This is not real now. It's going to be length, and we call it L1. L1. Apply. And OK. Let me go create our equations. So f of x, click on the pad, this thing, add the formula equal to L1. Now, the only thing that we need to do now is the number of the pockets that we made. If you go to the base, under the pattern, under the circular pattern, it shows you all the stuff that you currently. There is 4 because that's how I made it. So I want to say this thing, add a formula equal to rename parameter, the number that I specified to be 6, but I can change that. Okay, apply, okay, and let me actually bring the shaft into our view and update. Okay, we seem to have a problem somewhere. We're going to find out what it is. Something, I must have done something wrong somewhere. So obviously it's right there. It's in the sketch. And let me see. We're gonna have to debug this thing now. Okay, there's definitely something wrong here. So let me go and check my parameters. Make sure there's no unreasonable number. The big one is 6 inches, small one is 3. The radius is 0.5. Radius of those holes is 0.5. Oh, 0. 0 inches. So first, make this thing fun. You remember I say when you create these parameters, don't let them to be 0. And there. Do you remember what I say when you create parameter, make sure that you use meaningful numbers because the default is 0. If you put 0 and things go wrong, you panic right there. Okay, so let's start. Suppose that I want the number of the pocket, the number of pockets here to be 10. Okay, update. There we are. Suppose that the height of the space I want it to be 0.5. Okay. Okay. The inside radius. The inside radius is associated with the radius of the shaft, the inside radius of the base. And I made both of them equal to RS. So if I make this thing 4, 5, apply, they change. Now this radius, obviously the radius of that hole is too small for that. So we make it 0.25. You get the picture? I think we're good. So this was the second problem that I did for you. I did not bother worrying about material and part name to be string parameters, but the previous one, that was done in the previous one. And as I said, on the test, if we are asking you to create some constraints, make sure that the constraints are made, otherwise you lose some marks for not having them. Right now you can see that if I move these things, here, if I update, because I put the sufficient number of constraints, they snap back to where they're supposed to be. All right, folks, good luck. You can make your own problems and try it. There will be stuff like this on the test.